Today we're looking at solving equations where absolute value is within the equation. So first let's review absolute value. When we are finding the absolute value, we want to know how far away is that number from 0 on the number line. So when I'm taking the absolute value of 5, 5 is 1, 2, 3, 4, 5 spaces away. So the absolute value of 5 is 5. Looking at negative 5. How many spaces away is negative 5 from 0? 1, 2, 3, 4, 5. The absolute value of negative 5 is also 5. When you take the absolute value of a number, whether it's positive or negative, the answer will always be positive because absolute value represents distance, and distance or length is always positive. So the type of problems we're going to look at today looks like the absolute value of x is equal to 5. And we need to know what values of x after we take the absolute value of it will give us 5. And if we look at our work above, there's two different answers. When I take the absolute value of 5, the answer is 5. But when I take the absolute value of negative 5, the answer is also 5. So we're going to be looking at two different possible solutions when solving for absolute value. So for example 1, we have the absolute value of x minus 4 is equal to 6. I like to start off by splitting my solutions or my equations into two sides. One to represent positive 6, so I'm going to write x minus 4 is equal to 6. And 1 to represent negative 6. So I'm going to write x minus 4 equals negative 6. The reason I'm doing this is because I just showed there's two different ways to get 6 when taking the absolute value. If I take the absolute value of 6, I get 6. If I take the absolute value of negative 6, I also get 6. So I have to solve 2 times. So once I have the setup of my split, positive and negative 6, I solve just like we did last week by adding 4 to both sides. So x is equal to 10. On the negative side, I add 4 still, and I get x is equal to negative 2. Now I know I said absolute value will always be positive, but the variables are allowed to be negative, and I can check this. If I plug in 10, I want to make sure that when I take the absolute value of 10 minus 4, I get 6. 10 minus 4 is 6. Once I take the absolute value of 6, it is 6, so that checks out. Then I want to check with negative 2. So I plug in negative 2 minus 4. I subtract that to get negative 6. The absolute value of negative 6 is positive 6. So both solutions work out. Even with absolute value, there are special cases. So if I'm taking the absolute value of 3x plus 1, they want to know when is it going to equal negative 5. No matter what number I plug in for x, whether it's positive or negative, I'm going to take the absolute value at the end. Once I take the absolute value, I'm always going to have a positive answer. Therefore, I can never get negative 5, and our solution is no solution. Example number 2, we have to do a little bit of cleaning up before we're allowed to start with our split of positive and negative for absolute value. So I want to isolate my bars and get them completely alone. So I'm going to add 10 to both sides. So I'm looking at the absolute value of 3x plus 9 is equal to 6. Now I'm able to split to solve for positive 6. So I'm looking at 3x plus 9 is equal to 6. And then solving a second time for negative 6. 3x plus 9 is equal to negative 6. And then this is normal two-step equations that we did week 2. So I subtract 9 from both sides to get 3x equals negative 3. Divide 3 on both sides to get one answer of x equals negative 1. On the right-hand side, I subtract 9 from both sides to get 3x equals negative 15. Divide out by 3 for a second solution of negative 5. It's okay that my solutions are negative. I'm going to go back in. You can go into the original or the solved for. I like to go into the solved for equation. So I want to test to see, is 3 times negative 1 plus 9, once I take the absolute value, is that 6? So 3 times negative 1 is negative 3. I add 9 to that to get 6. And yes, the absolute value of 6 is 6. I check a second time with negative 5. 3 times negative 5 is negative 15. Once I add 9 to that, I get negative 6. Take the absolute value of negative 6 to get 6, and it checks out. For example B, I have 2 steps to isolate my variables. I'm going to add 3 to both sides. So I'm looking at negative 2 times the absolute value of 5x minus 1 is equal to 14. My bars are not by itself, but because a number beside anything means multiplication, I'm going to do the opposite and divide. So I'm looking at the absolute value of 5x minus 1 equals negative 7. And hopefully a little red flag popped up in your head because we're looking at absolute value, which should always be positive, being equal to a negative. And that is just not possible. So our answer is no solution. Example number 3 is when we have absolute values on both sides. It is good that 2 is positive, so I don't have to worry about any special cases. So I get to split. I'm going to set 4x minus 10 equal to positive 2 times the quantity of 3x plus 1. And I'm going to solve a second time for the absolute value now is going to be 4x minus 10 is equal to negative 2 times 3x plus 1. Then we solve our multi-step equations just like we did last week. So I'm going to start off by distributing to get 6x plus 2. I'm going to subtract 4x from both sides. So I have negative 10 equals 2x plus 2. Subtract my 2, so 12 is equal to 2x. Finally divide out, so x is equal to negative 6. That is one of my solutions. I'm going to solve a second time with negative 2 now. So 4x minus 10 is equal to negative 2x minus 2. Sorry, negative 6x, I made a mistake. Minus 2. I'm going to bring my negative 6x over by adding 6x. So now I'm looking at 10x minus 10 is equal to negative 2. I add my 10 to both sides. So 10x is equal to 8. Divide. And my second solution is 8/10 or 4/5 if you prefer fractions. I could plug back in to check to make sure that the left side is equal to the right side, and both of these are. My last example deals with this idea of extraneous solutions. So they are solutions that don't actually work when we check them. So since 4x is positive, I know it's not a special case, so I'm going to split into 2 sides. I'm going to set 2x plus 12 equal to positive 4x. And I'm going to solve a second time by setting 2x plus 12 equal to negative 4x. So for my positive side, I subtract 2x to get 12 is equal to 2x, divide by 2, and x is equal to 6. That is one possible solution. I'm going to solve for my negative side. So I subtract 2x from both sides. That leaves me with 12 is equal to negative 6x. I divide by negative 6, so my second possible solution is negative 2. So they asked me to check my work, so I'm going to plug in. I'm going to test to see is the absolute value of 2 times 6 plus 12 equal to 4 times 6. So I just plugged into our original equation. Simplify, 2 times 6 is 12. Once I add that to 12, I get 24. Absolute value of 24 is 24. Right-hand side's a bit easier. 4 times 6 is 24. Perfect. Checks out. I'm going to do the same thing with negative 2. So does the absolute value of 2 times negative 2 plus 12 equal 4 times negative 2? So I simplify. 2 times negative 2 is negative 4. I add 12 to that to get 8, and the absolute value of 8 is 8. On the right-hand side, 4 times negative 2 is negative 8. So this does not equal one another. Therefore, x equals negative 2 is an extraneous solution, and our only solution is x equals 6.